This talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
Taylor-Coyer flows is a turbulent fluid motion created in the gap between the two rotating cylinders. The traditional reason-based methods are only able to capture the small-scale coherent structure. The detection of the large structure depends on the 2D cross-section, which is not the true configuration. We adapt the feature-level set methods and the density estimation to combine multiple attributes and use them as the filter to separate large and small-scale structure.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Spot SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives users multiple perspectives of details with different granularity about the impact of SDC on an application's output. It also provides novel insight into how silent error propagates through a program's execution.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
We present Lyra2, a system for designing interactive visualizations by demonstration. To design interactions in Lyra2, users directly manipulate the visualization canvas. The system interprets demonstrations using heuristics and suggests possible interaction designs. We find that Lyra2 enables rapid prototyping of an expressive range of interaction designs. We're excited to share this work with you.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
We present VIS, a tool for visualizing hypergraphs where edges can connect any number of nodes. VIS is the first technique to display hyperedges with no overlap or crossing. Vertices are represented as rows, time periods flow from left to right, and groups can be shown on the left. We designed the layout for readability. VIS shines with mid-size hypergraphs and it allows detailed analysis. We tested VIS successfully using publication datasets and data from historical documents.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
CarxS is an authoring system which enables rapid creation of zooming-based scatter plot-like visualizations in just tens of lines of JSON. We contribute a declarative grammar for such visualizations, which captures a large design space. By working with multi-node database spatial indexes, CarxS enables interactive browsing of billions of data points. Come listen to our talk to learn more.
We present the first generic design space and library for visual piling. Inspired by physically piling paper documents, visual piling describes an interface for spatial organization of visual artifacts into piles of partially overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
We present Strat Graphics, an approach for designing data-agnostic and fully reusable visualization templates. Strat Graphics follows the inverse workflow that common data-driven systems. Rather than starting from data, designers construct visualization structures without relying on a data schema. Data tables are shaped later from the structure of graphics. We demonstrate the power of the approach through a gallery of visualization examples.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the ADM-VIV matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user-selected path to justify and reason the AD analysis.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
Linking and brushing is very useful for interactive video data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahalanobis brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brushing accuracy.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex datasets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Mel complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system, and
Welcome back, everyone, and thank you for joining us for the last session of BELIV 2020. Today, this last session will be about design methods and extensions, considering how we move forward in terms of design methodology. And we have 3 great paper presentations lined up, followed by a Zoom breakout discussion. So to kick things off, I'm going to turn it over to Damla Çay, and she's going to give her talk on her paper entitled Understanding User Experience of COVID-19 Maps Through Remote Elicitation Interviews. I look forward to the presentation. Take it away, Damla.
Hi everyone, I'm Damla Çay, and today I'll present to you our work titled Understanding User Experience of COVID-19 Maps Through Remote Elicitation Interviews by me and my colleagues Nagel and Asim, Evren, Yantac. I will start by explaining our motivation, move on to the background of this method, and finish with the details of our study and our lessons learned. So why did we apply this method for COVID-19 visualizations? We believe that for events that affected many people deeply on a personal level, it's important to investigate user experiences beyond performance measures to capture the richness of their experience. And to do this during the pandemic, we needed to adapt co-located evaluation methods for remote settings due to existing mobility disruptions. Elicitation interview, also known as microphenomenological interview, is an interview technique that aims to capture rich experience while minimizing biases introduced through post-rationalization. Our lived experience includes our sensations, thoughts, actions, emotions, and feelings. As Petit-Manjean describes, this method starts from the observation that a large part of our experience remains usually unnoticed. Whether we are touching, seeing, listening, imagining, whether we are performing a concrete or an abstract activity, a large part of this activity, although lived through subjectively, is not immediately accessible to reflective consciousness and verbal description. Elicitation interview, or EI, is a method of descriptive phenomenology, initially used by psychologist Vermesch in the early 90s, as he was aiming to transfer the implicit knowledge of experts to students to help them work around cognitive blocks. Later on, this method was used with any type of lived experience. The method was used in HCI field as well. Light explored the experience of text entry into web interfaces, and Obrist used them to understand how people verbalize their tactile experiences. For data visualizations, Hogan et al. Used EI on simple static visualizations and provided a useful guide that frames the questions for visualization studies. In another study, they focused more on the haptic and auditory data representations. Novak et al.'s focus was on narrative visualizations with limited interactivity, which also had emotional aspects. There have been no studies on more complex interactive visualizations. We believe applying EI to complex interactive visualizations is important, as interactivity is a key element. And remote interviews in general have many advantages in terms of reducing cost and increasing accessibility by removing geographical and mobility constraints. On the other hand, challenges were reported regarding connectivity and rapport. Poor internet connection can cause calls or recordings to be disrupted. While studies found remote interviews supportive for building rapport, they caution against a deceptive closeness between the participant and researcher. So an elicitation interview requires a mental state that enables the evocation of the lived experience. The participants should feel as if they were living that moment. This state enables acquiring details that would otherwise go unnoticed. To create such a mental state, EI uses a special questioning technique and interview structure. The interview is conducted in a quiet place without any distractions, and during the interview, open-ended and content-empty questions are asked in the present tense to evoke the experience. The questions are what and how questions, no why questions are asked to avoid judgments and post-rationalization. The interviewer observes specific cues to understand if the participant is in an evocation state. Speaking in the present tense, breaking eye contact and gazing into space, taking pauses and slurring speech are some of the cues that indicate the participant is in evocation state. We primarily used Hogan et al.'s interview guide, and the questioning technique has an iterative structure. The level of detail increases through the interview. The questions themselves generally don't introduce new information, but they aim to reveal the actions, sensations, and feelings of the participant at an increasing level of granularity. The interview has 6 phases. The first phase is notifying the participant about the aim of the study and the nature of the interview, that it can go deeper into experiences than regular interviews. The second step is commencing the interview using the phrase, "If you agree, I would like to go back to the time when you started the experience." Then the questions of when and where the experience happened are asked. After this, the third phase begins, where the evocation state is induced through visual, auditory, kinesthetic, and emotional questions. Some examples of these questions are, when you are there, what do you see? What are you hearing? What are you feeling? The fourth phase is diachronic stage, and it aims to understand the temporal structure of the experience, how it unfolded over time. Example probing questions that mark the key moments of the experience are, how do you start? What do you do then? What happens at the end? How do you know you have finished? After this temporal structure is defined, the interviewer moves on to the synchronic structure to deepen the episodes defined in the previous stage. Thus, probing questions are more fine-tuned versions of the evocation stage questions, revealing the visual, auditory, kinesthetic, and emotional sensations in greater detail. If the evocation state is disturbed at any point, the interviewer goes back to the evocation stage, the third stage, to induce it again. At the sixth and last phase, the interviewer reformulates the key moments of the interview and asks the participant if they have anything to add. So we conducted the remote interviews with 7 participants from diverse professions. We asked their previous experience with data visualizations and introspective practices, such as meditation, yoga, or mindfulness. We asked this because in previous studies, researchers found that participants with experience in introspective practices were more successful in focusing on and communicating their inner thoughts, actions, and feelings. And for this study, we selected 2 interactive COVID dashboards, World Health Organization's and Johns Hopkins University's COVID-19 dashboards. We chose interactive COVID dashboards as the topic is urgent and the previous studies haven't explored this method with exploratory interactive visualizations. And we selected these specific visualizations as they were both from reputable and well-known sources, both included similar types of information, both had a prominent spatial visualization, yet 2 websites differed in terms of visual style. When planning the video call, we asked participants to select a time and space where they can be away from distractions. We conducted the EI and asked post-interview questions about their experience with remote activities in general and what they think about the interview being remote. So the interviews created insights about how the users start their experience, what attracts their attention, how do they feel, how do they explore, and how do they decide to finish. In our case, we observed that the choice of colors and design can greatly impact users' perception of the topic, even when the data is very similar. In general, participants found the WHO to paint a positive picture, while GHU created a sense of danger. Participants explored the map to confirm certain aspects of global pandemic events, learn about the local effects, and look into the data about personally relevant places. All these relate to how people contextualize data based on their personal experiences, which confirm similar findings of previous studies. And we observed that participants were prone to be easily overwhelmed by the data. During the interviews, they limited their time and mostly refrained from deeper analysis. In the recruitment and planning process, we had many cases of cancellation and rescheduling. Some participants requested to be interviewed spontaneously. While we cannot compare rates with physical interviews, we believe that remote interviews enabled more room for leeway. This might have a negative effect when multiple interviews need to coordinate, but if there is room for flexibility, remote interviews can allow adjusting to participants' schedules, therefore requiring less effort for them. Our participants had diverse levels of introspective practices, but we observed no major differences between participants with or without prior introspective practices. All of our participants visited the website from their homes and joined the interviews remotely. This setting fits the recommendation for conducting EI in a quiet place, as well as using the same environment where the original experience happened. On the other hand, our study setup created room for digital distractions. In a physical setting, the experience itself and the interview are separated. First, the visualization is shown, or the experience happens, then the interview happens. In previous work, the visualization wasn't shown during the interview, as this might disturb the evocation of the original experience and introduce bias. In our case, it was just a tab away, and some participants mentioned the urge to open the web pages during the interview when they couldn't remember certain details. In future studies, this can be prevented by reminding participants to keep everything else closed other than the video chat software, or by using different mediums for the interview and the experience. If they use laptop for the experience, the interview can be conducted via mobile phones. The visual cues for evocation state were easy to identify. Since there is no eye contact in remote talks, instead of breaking eye contact when thinking about the experience, participants simply looked away from the screen and gazed into space. Overall, the participants expressed that the interview being remote wasn't really different from it being physical, and some even expressed that they felt more comfortable and safe. In summary, we conducted elicitation interviews remotely with interactive exploratory visualizations and discovered that despite the complexity of these interfaces, remote EI was able to create insights about the user experience, including sensory and emotional aspects. But the remote nature of the study created new types of distractions that might hinder the process. In future studies, this method can be combined with additional data sources. In neuroscience, EI is sometimes combined with fMRI data. For remote visualization studies, the actions during the experience can be logged or recorded, or participants' face can be recorded for recognizing emotions. Thank you for listening. I can take questions if you have any, and you can reach us later from Discord channel and through Twitter as well. These are our Twitter handles. Thank you.
Thank you so much, Damla, for that great presentation. So we have a few questions, a few discussion points coming in over Discord. And the first one, very practical question, going back to the methodological piece you mentioned at the beginning. What is it about why questions that make them discouraged in elicitation interviews?
It might introduce new types of information that is actually not the part of the original experience. The participant can feel the need to justify some things, even though they didn't felt in that moment where the original experience is happening. When you ask, why did you do this? They might think, okay, what should I answer? Or like, they might try to rationalize the idea after the experience itself, thinking what should it be rather than what it was.
Right, that makes good sense. So following up another question here, in the study you did, you looked at COVID-19 maps, which, that's, as you pointed out, highly relevant to what's going on in the world, people's lives, things taking place on a daily basis. And in that sense, it's great that you're looking at that. It also makes them potentially emotionally charged, politically charged. And so how do you think that the emotional response, potentially visceral response, changes the elicitation interview process? What do you think are the, compared to something that maybe a bit less connected to a person's life?
I think it's important to understand the risks and adjust during the interview. If you observe, if the interviewer observes that there's a disturbance, then they should step back, I think. In my case, just in the pilot interview, I got a feedback saying that the interviewee was disturbed, that I asked several times how did they feel about something. So I had to tune that back and only ask once, or like being mindful of their emotions and how are they reacting. And before the interview, like making sure that they know they can stop anytime. I also try to include like examples of the level of depth that this interview will be going through. So that was my personal ways of adjusting to this emotional aspects.
Right, so being very much in tune then with what the person is going through, reading their body language, thinking about those things, makes a lot of sense. Now, how do you expect that the elicitation interview process is different when you move from, say, non-experts to domain experts?
I don't think it's, of course, it depends on the experience. I think this method is meaningful when the participant has a personal, there is a personal relevance. So in the case of domain experts, I haven't applied this method with domain experts, but I think that's an interesting question. For the same experience, how do these two experiences differ? And it's also like projecting the method to where it originally came from. Like it was for capturing experts' experience of like how they live through something.
Fair enough, fair enough. So in terms of just one final question for you here, for which, this is from the audience, for which goals of visualization research is the elicitation interview approach most applicable due to its advantages and disadvantages?
I think if there's a message that should come across, I mean, it's the aim of the visualization is to give a message across. I think this is a like relatively quick way to understand if that message is coming across or you are creating the experience that that is intended. For those types of things, and for the types of visualizations that have some type of personal relevance to the user, and I think it's also useful when the experience extends the visual to tactile or auditory senses. And for example, it would be interesting to see like AR, VR applications, visualization applications, how people experience them. And this might give, I think this might be an insightful method to understand how people live those experiences.
Right, right. I think I'll just add one quick follow-up question there. When you were mentioning it, I mean, that makes good sense. You can imagine that along the visualization pipeline, as we're making visualizations, one could perhaps do elicitation interviews with very early prototypes versus through to fully deployed systems. Do you have any thoughts about how early in the research process we can start to take advantage of elicitation interviews?
I think as soon as you have something that you think is somewhat close to the end product, I think it can be somewhere in between iterations through the end. It has been used like with more finished visualizations until now. But of course, it can be used to understand like how people do things in generally to form the visualizations themselves. That's an area that haven't been studied yet. But that can be a useful area as well, I think.
Well, thank you so much for your great presentation and for answering the questions. With that, well, we'll move on to the next talk. Thank you so much, Damla.
Thank you.
So our next talk will be by Michael Oppermann. He's going to talk about his paper, Data First Visualization Design Studies. And with that, I'll turn it over to Michael. We look forward to your talk.
I'm Michael Oppermann, and I will present our paper on Data First Visualization Design Studies. This is joint work together with Tamara Munzner. Most people in this session are probably highly familiar with design studies, so I will only provide a brief definition. Quoting the design study methodology paper, a design study is a project in which visualization researchers analyze a specific real-world problem faced by domain experts, design a visualization system that supports solving this problem, validate the design, and reflect about lessons learned in order to refine visualization design guidelines. The design study methodology, or DSM for short, provides guidance for this type of applied visualization research, including a 9-stage framework, which has been used frequently over the last few years. The DSM suggests to connect with domain experts at an early winnow stage, to understand their problems, and to find out if there is a relevant research question. This winnowing process can take some time. A careful selection is necessary because not all potential collaborations are a good match. We now characterize this approach as a stakeholder first ordering. But we argue that this framework falls short of capturing the nature of data first design studies, that are primarily initiated by acquiring an interesting real-world dataset rather than selecting a specific stakeholder at the beginning. In a data first design study, the selection of the initial data constrains appropriate choices for stakeholders. The VIS researcher contacts multiple potential stakeholders, presents the data opportunities, and conducts a problem characterization. Focus stakeholders are then carefully chosen based on the match between data and tasks. This data-first process hasn't been explicitly analyzed in the VIS literature, but we realized that they occur frequently, for example in class or side projects, visualization design competitions, or in research contexts. The motivation behind this approach stems from our own experience in conducting data-first design studies. In our BELIV workshop paper, we contribute a refined and extended framework for data-first design studies to provide guidance and to highlight the differences to the original DSM. We reviewed 64 publications to find out if other projects indicated data-first ordering explicitly or implicitly as well. And we discuss a range of opportunities and risks of this special type of design study. We also reflect on 2 previously published studies that guided our initial thinking. I will compare our data-first framework to the original 9-stage DSM framework. The learn stage remains unchanged. It is about the visualization knowledge in general, and independent of the specific domain problem. A major change is to add an early acquire stage at the beginning. A visualizer encounters, collects, generates, or obtains access to a dataset, and begins to develop a data abstraction. Data sketches can provide first insights. What type of data am I working with? Are there any data quality challenges? What is special about this data? And most important, who would benefit of seeing and exploring it? We move the discover stage immediately after and rename it to elicit, to emphasize its focus on tasks. The visualizer reaches out to multiple potential stakeholders, explains the initial data abstractions, and learns about unsolved stakeholder needs. The goal of the winnow stage is to assess and prioritize potential stakeholders. How frequent are their data-relevant tasks? How central are these tasks to the stakeholder's primary mission? and how many people in the organization deal with these tasks. Some nuances differ in the cast stage, where the goal is to identify collaborator roles. Here, it's important to distinguish between data producers and data consumers. The design stage is narrowed to cover only visual idioms and interactions. The data abstraction takes place earlier in the acquire stage. The subsequent stages, implement, deploy, reflect, and write, remain mostly unchanged, with some small adjustments, for example, to reflect and report on the peculiarities of this data-first process. Here you can see a direct comparison. Similar to the original framework, the data-first stages emphasize iteration. Additional data sources may be incorporated, and data and task abstractions are refined continuously. We had our own direct experience with projects that started with specific datasets, but we were also interested if these data-first approaches have been explicitly or implicitly described in the literature. In total, we reviewed 64 design study publications from the last 2 decades, and we identified 16 potential cases that indicate characteristics of a data-first design process. We searched for any statements that suggest that a design study began with data and doesn't exhibit a very clear stakeholder-first ordering, for example in the motivation and process sections of a paper. An accurate allocation to a stakeholder-first or data-first ordering is not always possible in this type of retrospective analysis. These decisions are our own qualitative judgment calls and are based on limited information from the publications. It was particularly difficult to know when stakeholder engagement began and who provided the data. And often it was difficult to disambiguate between a researcher being their own stakeholder versus a data-first process. Researchers with extensive domain expertise may be qualified to self-validate a visualization solution, but our suggested data-first process largely focuses on external domain experts. Nevertheless, we identified 16 potential cases, suggesting that data-first approaches are more common than may be explicitly reported. Many authors use the design study methodology as a guide to describe their process, and we hope this paper encourages authors to be more upfront and center about the various flavors of design studies. Based on our own experience and the review of published projects, I want to now briefly discuss opportunities and risks of our proposed data-first approach. Data-first design studies can be an alternative avenue to approach VIS research collaborations, and allow possibilities that don't fit in the traditional DSM process. We can roughly compare to market pull versus technology push dynamics in product innovation. The originally acquired data is used to push ideas from an outside perspective instead of pulling analysis questions from a domain expert. Starting a design study without real data is a common pitfall, so access to real-world datasets is a major advantage and allows the creation of data sketches and technology probes early on. Addressing the needs of multiple stakeholders might lead to conflicting tasks and an ever-expanding project scope. In a data-first design study, the primary data source serves as a guide to delimit the problem space and to select matching stakeholders. Besides these opportunities, a data-first process may introduce risks and tensions. For example, a delayed involvement of domain experts and hypothesized instead of verified tasks. Or to converge on a specific idea too early and to develop a full-fledged prototype without much stakeholder engagement. When you have data at your fingertips, it is tempting to implement something right away, but technology probes should be limited in functionality and open-ended to avoid wasted effort. Stakeholders shouldn't become just design verifiers. In the worst case, the search for potential stakeholders may not succeed, and a successful design study wouldn't be achievable. In this case, other types of contributions, such as a novel visualization technique or algorithm, may be possible. A less extreme situation is when there is only a small number of potential users, and significant time is spent on promotion instead of on the actual research questions. A clear match between data and stakeholder tasks is often not immediately obvious, especially when a proxy measure stands in for a variable of interest. A misinterpretation can lead to project detours or to a failed design study. When users see their own data or data similar to theirs, they are often enthusiastic and conjecture about the many different ways the data might be useful. A central concern is to understand whether the visualization addresses a core task, an actual need of the target user group, or if it's only of peripheral relevance in the long term. Decoupling the data producer from the consumer requires additional considerations and may increase the responsibility for the VIS researcher. Another risk is a premature finalization of data and task abstractions, keeping the focus too narrow on the initial data without considering the broader problem space, and ensuring extensibility from an engineering and design perspective. In our workshop paper, we reflect on two of our own projects that we now consider data-first design studies. Ocupado, where we created a set of decision support tools that help stakeholders from different domains analyze building occupancy. And the Bike Sharing Atlas. We recorded station fill levels from hundreds of bike sharing networks and made the data accessible to different user groups. I will now use Ocupado as a case study to explain why we think it's a data-first design study, and I will go through all the stages of our proposed data-first framework. We collaborated with the sustainability startup Sensible Building Science, which was our data provider. The company collects Wi-Fi device signals without installing additional sensors and uses this data as a proxy for human occupancy. This is a very cost-efficient method to estimate occupancy in hundreds of rooms across many buildings. Our industry collaborator used the data to dynamically adapt heating, ventilation, and air conditioning in building management systems. We thought, wow, this data is really interesting, and we suspected that it could be useful for decision making and resource management if users can see the data visually. We acquired samples of this data that we refer to as location-based counts. These device counts for each zone or spatial region are stored every 5 minutes, and we get a spatial time series over time. We don't record any trajectories or device identifiers, which leads to significant privacy advantages. In the elicit stage, our goal was to understand the tasks of potential stakeholders. We conducted a series of interviews with users from 9 different domains, and we tried to find out if they would benefit of exploring the data or not. We did a full task abstraction for all domains to find out if there is a match. We conjectured that this type of data can be actively useful for certain tasks, but is not appropriate for others, for example when it's important to see movements or highly accurate head counts. After a series of interviews, we assessed and prioritized a set of potential stakeholders, and we considered whether to incorporate secondary data to facilitate additional tasks. As a result, we identified stakeholders in 5 domains: custodial services, space planning, building management, classroom management, and data quality control, because the data provider was also selected as a target user. Across all our stakeholders, we identified 4 high-level tasks. First, confirm assumptions or previous observations. A specific instance is, for example, do students always occupy a certain room in the evenings or on weekends? Live monitoring. Which rooms are empty or busy at the moment? Communicate space usage and justify decisions. For example, did the usage of an informal learning space improve after renovation? And in addition, use Ocupado to verify if the recorded device counts are correct. What is the minimum size that could be reliably captured by using Wi-Fi access points? The cast stage is similar to the original framework, with the goal to identify roles. The promoter role is essential. It is important to reach out to stakeholders to present data and visualization opportunities. Another difference to most traditional design studies is that the data producer and the data consumer roles are held by different people and may require particular consideration. For example, in Ocupado, we had data for some buildings, but a stakeholder wanted to analyze different regions on a university campus. In the design stage, we designed interfaces targeted to specific space-time slices. Our original assumption was that we would design different interfaces for different stakeholder domains, but instead, we found a significant overlap between their tasks, and the questions could be captured by looking at different space-time data granularities. The remaining stages, implement, deploy, reflect, and write, were mostly aligned with the original DSM framework. We implemented and deployed multiple interfaces, and our industry partner adopted Ocupado as a frontend for the Wi-Fi data collection platform. Here you can see some screenshots of these interfaces. You can find more information about the Ocupado project in our VIS paper that was published earlier this year. In our workshop paper, we contribute the first characterization of a data-first design study. We present the review of previous design studies, a framework adaptation based on the original DSM, and the discussion of opportunities and risks to provide practical guidance. Thank you.
Thank you so much, Michael, for that great talk and that your interesting work on design methodology. So just a few questions coming in here from Discord. How is it difficult to gather relevant data without a collaboration of a stakeholder? Wouldn't it be helpful to have a domain expert to explain the issues they are having with the data?
I think there's two different issues. So certainly it's really helpful if you have a collaborator, and I think that's also a goal of a design study, to have a collaborator and they tell you if there are any issues with the data, if they need any secondary data sources that might help to solve a specific problem. But then there's the data collection part. Yes, in this traditional design study methodology, the collaborator comes to you with a data set, and you start off with the design study process. But in data-first design studies, very often you collect data or use other data sets as a proxy, and the collaborator might not have heard about this data source, and so you present new opportunities to use certain data sets.
Right. That makes good sense. One of the comments was, what I like about the idea of design for a data-first design study is that it seems to create opportunities for more diverse target user profiles versus only considering one homogeneous group of domain experts. Did you have this goal in mind when you went down this path? What do you think about that comment?
Yeah, I think that's a very good point. Especially in this bike sharing Atlas project, we started off working with a bike sharing operator in Vienna, and we thought, oh, this data is really useful and it could help many other people that work on infrastructure project in a city, for example. So you get this diverse set of users, and I think that's a great opportunity for other data-first design studies that you expand. And I also know that the VIS group in London, Jason Dykes and Joe Wood had a similar bike sharing project where they also had this multi-channel approach and reached out to different user groups. And I think that would be really interesting to see this more often in VIS, to have very diverse user groups.
Yes, and on that, I actually want to go to the study you were talking about, that work by Joe Woods. Last year, Joe Woods, I'll admit, with myself, published a paper in which we talked about design by immersion. The idea that a VIS researcher would immerse themselves in a target application to inform visualization design and design processes. I'd be interested to get your thoughts on how that immersion and design by immersion relates to data-first driven visualization. You cite that work as one of the case studies for your work too. So I'd be interested to get your thoughts.
So at the beginning of this data first process, you are your own stakeholder. You maybe come up with certain tasks to explore the data, maybe create initial prototypes. But then it's really important to expand this kind of not just work as your own stakeholder, but really look out for collaborators, and because there's a great risk that otherwise you go in the completely wrong direction and don't verify it with actual users. So it's very important to think about all the possible ways how the data can be used, but then it's very, very important to reach out to actual users soon.
Right, and I think that's one of the great, I think everybody wants to see that, more engagement with users. So I think that's a good point. Now the last question here, and then I think we'll need to get move on. How do you think the notion of a data-first design study relates to Michael Correll's critique of the heroic nature of design studies these days?
I think that's more a general critique of this applied visualization research. And I think some of the we had this interesting fireside chat today, and I think a lot of these learnings can be applied to all different types of design studies. It doesn't matter if it's a colon type of studies, not just data first studies. And it's I think more a general goal to make these studies more reproducible, better allow meta-analysis, have certain standards. And that's why it's very important for the data-first design studies to make the process as transparent as possible. With whom did you engage with the stakeholders? Why do you kind of ignore certain stakeholders, potential stakeholders that you talked about at the beginning? Why do you select a smaller set? I think these things are very important.
Do you think if you're your own stakeholder initially, there's a risk of a self-selection bias that you might seek out stakeholders similar to yourself?
Yes, there is a risk. That should be mitigated by looking in a lot of different directions. And really, if a visualization solution really helps them in depth, they are users that would really benefit this from the solution. Very kind of it's the primary task, and it's not just they look at it once. I think then they're great users, and it typically doesn't apply to a VIS researcher. It's more domain expert.
Well, thank you for your presentation and your thoughts, Michael. It's been great having you with us, and we'll switch over to our last presentation for this session. And Christian Knoll will give us a presentation on his paper, Extending Recommendations for Creative Visualization Opportunities Workshops. And I'll pass it over to Christian now.
So thank you very much for the introduction. Hello, everyone, and good evening from Vienna. My name is Christian Knoll, and I'm a PhD student with the Visualization and Data Analysis Group at the University of Vienna. On behalf of my colleagues, I would like to welcome you to our presentation on Extending Recommendations for Creative Visualization Opportunities Workshops. This work is a collaboration between the University of Vienna, the Austrian Academy of Sciences, and the University of Utah. One of the most important parts of the process of developing effective technology is the initial requirements analysis phase. This phase is critical to get right as it establishes the basis for all other design, development, and deployment efforts that follow. The requirement analysis is often a lengthy and time-consuming process, and a common approach for conducting requirements analysis is via interviews in multiple sessions with multiple stakeholders. To reduce the time and effort of developing visualization design requirements, Kurtzner et al. Propose a participatory approach called Creative Visualization Opportunities, or short CVO workshops. And CVO workshops minimize the time needed for the initial requirements analysis through the use of structured activities that encourage creative group brainstorming between domain experts and visualization experts. Creating an effective workshop is a design problem because practically infinite combinations of various workshop variables and methods are available, and they can be adapted to a lot of different domains. The original framework proposes guidelines for every stage of planning, executing, and analyzing workshops, and we frequently referred to these guidelines as we designed our own workshops, but found ourselves with many open questions about details not covered in existing guidance, and there is no further reporting on explicit guidance for CVO workshops. To address these problems, we conducted 4 CVO workshops in different settings and with different partnering institutions. In our paper, we report on our experiences running these workshops to provide further pragmatic guidance for using this approach in a diverse set of contexts. The workshops consist of guided activities in varying settings. We changed the structure of the workshops, so for instance, by using different orders of activities or changing the length of the workshop, and analyzed our experiences. We gathered and analyzed all the artifacts created in the workshop to characterize domain problems, the participants' needs and requirements for visual analysis tools, and potential barriers that could prevent ideas from being realized. In the end, 3 out of the 4 workshops led to the direct development of high-fidelity prototypes, which are currently in use by our partnering institutions. This provides evidence for the efficacy of CVO workshops in practice. Here you can see an overview of the 4 workshops that we conducted. Each of them focused on a different domain and topic and varied in the number of participants and facilitators, as well as the length and language used. Please note that all of the workshops were conducted before the worldwide COVID-19 pandemic. Based on our reflections on the experience of running these workshops, there are 2 contributions of our work. The first contribution is a set of 12 pragmatic recommendations for planning, executing, and analyzing CVO workshops that extend and complement existing guidance. These recommendations foster interpersonal dynamics, improve the efficacy of activities, and enable richer post-workshop analysis. A second contribution is guidance on how to analyze the diverse data and ideas created during a CVO workshop, which fills the gap in the existing framework. We recommend the usage of a method for analyzing workshop results called user stories, which is a commonly used technique in agile software development. We combine this method with the CVO framework to support developing visualization requirements based on emergent workshop themes. Before we go into more detail on the contributions, I will tell you more about the how CVO workshops can be designed. Our basic workshop structure consists of 5 activities: analogy introduction, wishful thinking, barrier removal, visualization analogies, and storyboarding. All of them structured around a specific theme based on the data the participants work with. Activities in the beginning and the core of the workshop are divergent to gather a broad spectrum of ideas, whereas activities near the end converge towards a specific theme. Some of the activities include vibrant discussions, so breaks in between them are very important to let participants rest. Now let's have a closer look at these activities. The first activity in all of our workshops was analogy introduction, where participants and facilitators introduce themselves. The participants share some basic demographic information like name, job and profession, place of work, and the topic they currently work on. Additionally, they are asked to answer a rather personal icebreaker question to encourage a trusting and friendly atmosphere for the upcoming activities. In one of our workshops, for example, we asked historians, if you could travel in time, which year or era would you travel to and why? In another workshop, we asked academics, if you could go back in time and redo your studies, what study program would you choose? So using icebreakers proved to be very effective. So I'm really curious, have you ever used an icebreaker? Let us know your favorite icebreaker or an idea for a funny icebreaker in a tweet with hashtag #myfavoriteicebreaker and the other 2 hashtags. My colleague is posting them in the Discord channel, so please just use them and write a tweet if you want to, and we are looking forward to some interesting tweets from you. After the introduction, the participants brainstorm about the workshop theme. They are asked to answer 2 questions regarding the workshop theme and data they work with. What would you like to know, and what would you like to be able to do? The participants put their answers down individually on different colored sticky notes. These sticky notes are then discussed in groups of 2, leading to potentially new ideas. This is followed by discussing and collectively clustering the ideas into different sub-themes with all of the participants. Afterwards, participants brainstorm about how they would be able to see that in the data, which is related to the answers from the previous 2 questions. Therefore, they split up into subgroups, each working on one of the sub-themes which were found during the clustering of ideas. So in the end, there is a large collection of ideas expressing the participants' needs with focus on what they would like to know, what they would like to be able to do, and how they would be able to see that. In barrier removal, the groups from the previous activity brainstorm about potential barriers that could prevent the ideas found in visual thinking from being realized. They are again asked to write their answers down on different colored sticky notes based on the questions: what are the barriers, constraints that prevent the ideas that we found earlier? And imagine that these barriers have been removed. What would be possible? The participants discuss the questions in their groups, and the answers are then collected and discussed on the whiteboard. One of the last activities is visualization analogies, where existing visualization projects are presented to the participants. This should give them an idea of what visualization is capable of and to encourage them to think outside the box. This is a rather passive activity. And in our workshops, for instance, we introduced lineup for listing and ranking attributes, tools that use world maps for exploring different kinds of geographic data, and even a tool that visualizes the sonic topology of a poem to show how text could be visually analyzed. The last activity is storyboarding. This is a very creative activity where participants sketch their ideas of a possibly interactive visual data representation based on the question, how could a visualization system based on the data look like? We provided them with a lot of materials like pens, different colored sheets, rulers, and so on to facilitate the process of creating the storyboard. The picture on the right shows a nice example of how messy this creative activity can get. So here's an example of a static dashboard that was created in one of our workshops. It shows how drug packages are moved across the world and gives the user detailed information on these packages. Another example can be seen on the right, where a dashboard for the university administration to plan courses in the upcoming semesters was sketched. In our third workshop, we also wanted to integrate the notion of interaction. So we decided to use cameras to capture short videos showcasing the functionality of the dashboard and called the activity video prototyping. On the right, you can see an example of such a video prototype, which was created during one of our workshops. So here you can see a video prototype showing a large network that is explored by the participant. The participant selects a subnetwork and a detailed graph with meta information on the nodes and edges is displayed. The participant explains the additional information in this view. And then clicks on one of the nodes to get more information on the selected node. So this is one short example of how a video prototype could look like. So after showing how CVO workshops can be structured, we are now coming back to our contribution. The original CVO framework proposes guidelines for every stage of planning, executing, and analyzing workshops. We frequently refer to these recommendations as we designed our own workshops, but we found ourselves with many open questions about detail not covered in existing guidance. So based on the reflection of our experience running the 4 workshops, we found new contributions that were not recorded in the original paper. The first contribution is a set of 12 pragmatic recommendations that extend the ones from the original paper And the second contribution is a 5-step guidance for analyzing CVO workshop by using user stories. So as a result of our reflection on the experiences running for CVO workshops, we give new pragmatic guidance for running these workshops in diverse contexts that complements and extends existing recommendations for planning, executing, and analyzing workshops. Unfortunately, there is not enough time to go into detail on all of them, but I would like to elaborate on 2 recommendations that we found especially interesting. Please refer to the paper for more information on the other ones. The first recommendation I would like to talk about is use participants' creative native language. Successful CVO workshops depend on active participation and vibrant discussions. Therefore, using a language with which participants are confident and comfortable is important. We experienced that at least half of the participants in one of the workshops seemed to be very hesitant to talk in English. They switched to their native language at certain points, which made facilitating the workshop difficult since some facilitators did not speak that language. Evaluating which language to use based on the proficiency and willingness of the participants in advance is crucial. We recommend using the language the participants use most often in their work for effective communication that encourages collegiality and increases the challenge of the engagement. The second recommendation that was especially successful in our workshop was try a VIS kit. In contrast to promoting low fidelity by sketching ideas, we simultaneously wanted to provide participants the opportunity to increase the fidelity of their prototypes or their storyboards through a visualization kit, which in short, VIS kit. After seeing how much time people needed to create a storyboard in the first workshop, we wanted to make the activity even more effective and efficient. The VIS kit facilitates the task of creating a storyboard by providing basic charts and plots and maps that can be cut out and pasted on the cardboard. Additionally, we provided cutouts of the visualization tools we presented in the visualization analogies. All the cutouts were available in different sizes and without axis labels, so they could be adapted in any way the participants want. Here's an example of a storyboard created in one of the workshops. It shows a dashboard with information on drug trafficking around the world. It combines a geographic view and other elements for detailed information. This group used lineup for showing and ranking individual drug incidents. On the right side, there is an example from a video prototype where the evolution of historical trading communities is shown. This group used cutouts of tools presented in the visualization analogies. Providing the VIS kit to the participants was a great success since it reduced the time needed to create a storyboard and made the storyboards even more clear. Our second contribution is a 5-step guidance that supports developing visualization requirements based on emergent workshop themes. We use the method user stories, and it fills the gap within the existing framework on how to analyze the diverse data and ideas created during a CVO workshop. As a first step, the project team transcribes, digitizes, and annotates all of the collected workshop materials, like, for instance, photos, voice recordings, sticky notes, or sketches, and so on. And in the second step, primary target user types are defined by using the analyzed workshop materials. Finding these user types can be achieved by going through the collected materials, such as sticky notes and storyboards, and grouping them based on the profile and background of the participants. At this stage, considering the diverse set of people the tool is going to be designed for is really important. In one of the workshops, for instance, we identified the following target user types: linguist, media researcher, and digital humanities student. In the third step, we define the most important actions like know, do, and see for each theme cluster by using the output from the visual thinking activity and label each of the defined actions with the user type. We found that using characteristics of participants who suggested and prioritized various actions to be a useful indicator of which user type to assign to the actions. The next step is to formulate user stories for each theme cluster and each user type using the following template. I'm a type of user I want to go to achieve so that I can reason for that action. Some examples are, I'm a linguist. I want to compare the similarity network of a word from one year with another so that I know if there is a change in the usage of the word. Or another example would be, I'm a media researcher. I want to search for a politician and see the distribution of sentiment scores in the media so that I can see if different media sources report with different sentiments towards certain politicians. Based on the user stories we defined in the previous step, a user story map with activities, tasks, and subtasks is created. At this stage, the project team is encouraged to have discussions about the priorities of different user stories and realign them on the board. The final alignment of the items can be used to define a group of user stories to be implemented in the first iteration of implementation. The remaining items can be saved in the backlog for further iterations. Please refer to the paper for more detailed information on user stories. So in conclusion, CBO workshops proved to be a powerful method for the initial requirement process. All of our workshops were a success in terms of supporting visualization experts in characterizing domain problems and gathering requirements from the participants. Currently, three of the workshops have led to the direct development of new visualization tools. And based on our experience of running these creativity workshops, we gave 12 pragmatic recommendations for planning, executing, and analyzing CBO workshops that extend and complement existing guidance. A second contribution is a recommended 5-step guidance for analyzing workshop results using user stories. In terms of future work, an interesting avenue to explore would be how CBO workshops can be adapted to run in a virtual environment. What are the hardware and software requirements that would be needed to implement a virtual workshop? Which of our recommendations are still useful in this context, and which ones have to be adapted? And how can we ensure that a creative environment that motivates participants and establishes collegiality over distance? These are some of the critical questions we're interested in exploring as we look towards running virtual CBO workshops during the COVID-19 pandemic and beyond. We are also interested in exploring how CBO workshops can be used or refined to inform other stages of visualization tool design, development, and deployment. Additionally, the recommendations we give in this paper are based on our experience of workshops that took place in different locations in Central Europe. With virtual workshops that could connect participants globally, it would also be interesting to further explore how the recommendations would need to be adapted to other social contexts, taking into account factors such as different participation demographics and social norms. This brings me to the end of the presentation. Thank you very much for your attention.
Thank you very much, Christian, for that great talk. It sounds like a great technique, and I hope I'll have the opportunity to use it. Diving into that piece, I mean, right now, many of us still are under, social distance guidelines and things like that. You mentioned at the end the idea of adapting, maybe to a virtual setting. Can you elaborate on that anymore?
So yeah, the first thing we have to consider is how can we transform all of the activities that we have seen in the presentation to a virtual context, basically. So there is a need for software, for instance, for creating collaboratively creating such storyboards. And I think it is a challenge in terms of creativity and motivation over distance to really get some great results out of the virtual workshops. So it needs a lot more thinking on that. And we have seen in our workshops that the creativity was really at a high when people saw all the materials that we provided them. And I showed one picture where it was really messy. So people were really getting into the creative process. And yes, and I think this has to be seen how this can be used to do this in a virtual context.
That makes good sense. So based on your personal experience, this is just a question from the Discord chat here. How have you ensured that participants, domain experts, often very busy and quote serious professionals, understand the value of conducting such creative sessions? Any tips, tricks that you'd like to share?
So in the beginning, in the planning process, we always talked to our stakeholders. We always had at minimum one person at our partnering institution, which we were talking to. And we had a look at the data and then discussed with our partner in the partnering institution what participants he has in mind for such a workshop. And yes, this is a question that came up a lot in our preparation phase of each workshop. So we wanted to make sure that the participants know what theme we are working on. And we created a report for all of the workshops to give to the participants after the workshop. And we informed them about that beforehand so that they know that they have something after the workshop, which hopefully they can work with. And yes, it's not always that easy to get, for instance, a full day workshop or time for a full day workshop from the participants.
Another question coming in from Discord. Do you have any thoughts about particular methods or strategies for engaging with participants to help them come up with as many ideas as possible in case they feel like they're hitting a mental wall or something like that? Any thoughts there?
That's a really good question. So in our cases, in our activities, we always had these group discussions. We asked them to, before they present their ideas to the other ones, we asked them to do little group discussions in groups of 2 to just talk to each other, and maybe if there is a barrier, that they can come up with new ideas together and then present the ideas to the group. So we did not really have that in our workshops that people had barriers or something like that. It is a collaborative process, and if they work together, there was a great amount of ideas. And yes, I think.
Well, thank you again, Christian. Thank you for your thoughts and the great presentation. We've now come to the end of the paper presentations. I would encourage all of the authors to take a look at Discord. There were lots of questions and comments that we couldn't deal with. So please check them out and respond. We're now going to switch over to our final Zoom breakout discussion session. I hope that you will join us. Remember that through the virtual BIS website, you can access the Zoom link. So please take this opportunity to join us on the Zoom call for some networking and discussion to cap off BELIV 2020. We look forward for you to join us. Well, thank you everyone who contributed to BELIV, everyone who attended and participated. It's been a great event and we have come to the end of BELIV 2020. We've come to the end of this steeplechase. I really appreciate everything, all of the discussions and connections that we've made, and I hope that you will go forward and enjoy the rest of VIS 2020. With that, I would like to again thank all of the other people who helped co-organize BELIV. If you have any feedback about the event, thoughts about future iterations, please reach out to us. There is the website for BELIV again, and you can go there to access papers. We'll also connect it to the YouTube feeds once they're posted. And stay tuned and look forward to BELIV 2022. And with that, I say so long and thanks for all the methodology. Enjoy the rest of VIS 2020 and bye for now.